This talk concerns our experience fixing broken instruments in our facility using DAC2Go, and we've done it with several different mechanical testers and had very good results. The common situations that we have had are that the machine simply quits running. Usually it's broken electronics, and the mechanicals are still quite good on the instruments, and that's not a surprise because electronics age and fail with time. And the world in electronics has changed quite a bit since these machines were first put together. We've also had some with software issues where the software is obsolete, or it's missing when we bought an instrument, or it was flawed and inadequate for recent tests that we've done and data comparisons that we desire to make. And we've had some where the computers that are run, the desktops and laptops, were obsolete. They basically were in XP and they used GPIB cards. And the problem has been the instruments are expensive and they're very expensive to fix. The vendors don't support the instruments anymore. They want you to buy new stuff. The software that's offered is very expensive. In addition, there are only a few really good, reputable, qualified repair services, and the software is really a problem. So what we decided to do is use the DAC2Go system integration tool and apply it to mechanical testers. Basically, the DAC2Go system consists of Excel-based software that controls high-performance electronic hardware. It can take inputs from sensors and put out signals to things like servo controllers and the like. And in fact, the DAC2Go also has a power modulator, so one can directly control a third or a half horsepower motor with the things directly. So when you go to fix dead instruments, as we found, what you want to do is keep the basic hardware and replace all the electronics and software. It's best to use the OEM limit switches and emergency stop if you can. People are used to those things, and you have to do it so it's safe, so the grounds are taken care of. There's no hazards that get introduced, and ones that were intrinsic in the instrument, some of those can be removed as well. So you'll see this as we go through the examples. What we've done is we've removed all the old electronics in most cases, installed new electronics and the controller, and we copied all the valuable features that were there to begin with, and then we added improvements. One of them that we found is that string potentiometers provide better data than traditional quadrature encoders, and also some people want to add extensiometers. So these help upgrade the performance of the instrument, and with DAC2Go you can also add automation if you're so inclined. Here's the first example. This was a little Mini 44, and we took the cover off of it and looked at it because it was dead. The servo controller board was bad. There was no software, no computer. And we noticed that it had a surprisingly oversized power supply with nearly lethal voltages on the thing. We replaced the power supply with simply a Dell charger from a computer, which was plenty powerful for this and plenty reliable. We used the DAC2Go PDR4 power modulator and the mechanical tester software, and we fitted it initially with both a string pod and used the quadrature encoder. Rather than replacing everything and tearing it out inside, we simply put a strip on the back of the instrument itself, a connector strip, and brought all of the information out, which really wasn't very much, because with DAC2Go we replaced all of the electronics functions, including the power supply. And here the thing is actually in action. You can see the DAC2Go software up on the right, and the press actually at this moment pulling on a spring. Example 2 is really more complete refurbishment. There was no motor, the electronics were faulty, there was no software, no controller. So we bought a new motor, added a string pot, removed all the old electronics, and this is how it looked. Here it is with everything taken out of the case. On the right-hand side is the general power flow through the thing when you use the DAC2Go. And here are actually pictures of it in place. The power supply is on the left, up underneath the black saddle. The DAC2Go boards are right here. And then a couple of the relays are here and the other relays are along the side. When those are done, we were able to put the case right back on it. So everything fit in. We used the original emergency stop button. The string pot was really pretty neat. The USB connection is made with a hole we put in the right side of the case. We added a couple of extra fuses for safety. And we used the DAC2Go Mechanical Tester Pro software. We also, in that software, put the wiring diagrams and schematics and whatnot on the Notes tab in the software itself. So it's fully documented. Now we have a couple of 4206s that are getting long in tooth. The electronics become problematic and they occasionally die. Recently we had one where the thing failed one day, and the best we could do was about $4,000 for a replacement used board that would only give us 30 days of warranty, and about a $4,000 service call. So we're looking at nearly $10,000 right off the bat. We saw there's plenty of room when you take the case off, as you could see on the left, to put all your electronics inside. So we did. On the right side you can see a plastic board with the relays and the power supply and all that right on it, fit right in place. There's two different places we could put the string pot, because we found the string pot gives better data than the quadrature encoders. We could put it at the bottom or the top, and we actually prefer it at the top. So on the left side you can see it from one view, and on the right side you can see it from the other view. We used a little stand and put a laptop usually on the thing. We've also turned around and upgraded the performance of some of our hydraulic mechanical testers. On the right side you'll see we had an old-fashioned meter box that would simply give us the maximum force before breakage, and we replaced that with the DAC2Go module, which is down toward the bottom center of the picture on the left, and the laptop. That gave us immediately the ability to get the whole force versus displacement profiles and do a lot of mathematics and a lot of comparisons of data. We also repurposed a 50-ton hydraulic press using the DAC2Go. And here you can see what was a manufacturing press is now actually a programmable hydraulic press. In all cases, we use the DAC2Go Mechanical Tester Pro software system. It's all Excel based. It's easy to customize and make it the way you want. It has built in already the common ASTM tests. It's higher resolution than the standard available software that's out there, and there are data comparison tools, so you can do a lot more with the results that you get. There's a lot more information about DAC2Go and how to use it and whatnot, both on YouTube videos and at the DAC2Go.com site. We've found this an excellent and powerful tool for this instrumentation and also for